Hey everybody! Seems like there are fewer of you than last week. But anyway, thanks for showing up, I guess, to week 2 of CS410J Advanced Java Programming here at Portland State University, summer 2013. Woo! Yeah, okay. Enough with the woo. Well, before we dive into tonight, I wanted to start out with, do you guys have any questions? So how was last week? What did you guys work on? There was very little, there was only a little bit of traffic on the Google Plus community. Has everybody joined the community? Because if you haven't, you probably got here at 5:30 thinking, oh, when's class going to start? I mean, that's what the other half of the class did, and then they left. But anyway, adjunct lecturer, you only need to wait 15 minutes for me. So, any questions about sort of the material we covered? I think a couple of you guys started the projects. If you haven't started the project yet, I recommend that you do. Nothing? All clear as mud? Have you guys been watching the screencasts? Yes? Helpful, not helpful? Is the quality okay? Can you see the video? Okay. Is this a good thing? Should I keep doing it? Okay.
I liked it.
Yes, you liked it? Okay, good. Well, I have to apologize. I've still got this cold. And maybe it's allergies or something. I don't know. But my voice is, well, as much as I like hearing the sound of my own voice, hearing the sound of my own voice is always weird. And when I'm sick and all kind of gravelly and raspy, it's even worse. So I haven't been, I want to let my voice rest a little bit, both for tonight's lecture and then also for the screencast. So I'm not as ahead in the screencasts as I would like, but I'll try to catch up over the long weekend and everything like that. Yeah.
Actually, so I asked about this last class, but in terms of when we should watch which lectures,
Yes.
I noticed that you have some stuff on there, and so is that the complete list?
Yes. So what's on like the course schedule on the class homepage is the complete list. Once I get a few more, once I get ahead of the lectures, I want to go back and add like links and stuff like that to here. But yes, I mean, so for instance, last week we talked about we did the programming language review. There's not a screencast for that, but like JUnit and Maven, I expect that you guys watched that last week and actually prepare for maybe not so much lecture this week, but certainly for the homework or for the programming assignment that is going to be assigned tonight. Oops, there we go. Core APIs. Let's see, the first 2 screencasts in the Core APIs, the ones that I put up. What was that? Sunday night and Monday morning or something like that. Anyway, the first one is on sort of the language APIs, string builder, wrapper classes, stuff like that. And then the second one was on I/O. You're going to need both of those to do Project 2. Sorry, Project 2. Yeah, and we'll talk about Project 2 tonight. Yeah.
Maybe you could just touch on this at some point. What's a repository manager for Maven?
A repository manager.
Yes, so
in what context?
Like Artifactory?
Okay.
Or like Nexus?
Yes. Okay. Really good question. So, do you guys understand what a Maven repository is? It's got all. Okay. So, one of the problems that Maven Maven helps out with is getting third-party libraries, right? Like we saw in our Maven projects, we use things like JUnit and Hamcrest. These are not libraries, the code that you wrote, it's the code someone else wrote. Actually, even my code, I suppose, like the human class or your abstract appointment book, things like that. It's code that I wrote, nothing. It's code that you wrote. And now, these are usually developed as like open source projects or something, and so out there, on the project's website there's a jar file that you can go and download. And before Maven, what a lot of people did was, you had to get the jar file in there so you could compile against it and then bundle it and then run with it too at runtime. And so what people ended up doing was like downloading the jar files, and they would sometimes, put them off on the file system someplace, or they would check them into their source code control. Well, source code controls, source code management systems like Git or Subversion or CVS or whatever, aren't very good with binary files. They're meant for text-based files like source code, right? It's not file management, it's source code management. And so it just got really messy because you go down this artifact, but then 6 months later, you don't know what version of the artifact it was, or okay, where exactly you got it from. So that was one of the big problems with building Java projects. There was all this third-party source code, and you had to manage it. Well, one of the goals in the Maven project was to make that easier. So the way they make it easier is they define this notion of a deployed artifact, and the deployed artifact has that group ID, so something like org JUnit or edu pdx cs399j, something like that. 410, sorry, cs410j. There's that notion. Then there's the artifact ID, and then the artifact version. And this uniquely identifies an artifact out there. So where is this out there? This out there is a Maven repository. So Maven also defines a repository format for locating artifacts. And so if you, and the repository format is the same whether or not you're talking about the local repository, which is in your .m2 directory. Let me make that a little bigger. Too big. Let's see, here's that. Okay. Maven 2 repository. So here's your local thing, and you've got org JUnit. Oops, maybe I don't have org JUnit. CS410J, and then examples summer 13, examples 2013.jar. So the whole idea, and so when I want to go find the artifact whose group ID is edu pdx cs410j, the name of the artifact is examples, the version is summer 2013, summer 2013, and it's a jar file. It'll go look for this this artifact. So this is the repository format. So it's this convention that Maven follows. So this is the local repository. It knows to look there in my local disk. Maven also knows how to go fetch this the same artifact using the same convention from websites over HTTP. And so then if you go to my website and you look in, what is it called? Maven 2 repository? Nope. Sorry, let me go look. Actually, I can go find that easily by looking in appointment booking the POM. Somewhere I should have. There we go. No, it's docs. There it is. So, okay. So there's the local repository. There is the Maven Central repository, which contains a whole, tons and tons and tons of deployed artifacts. It's where your JUnit lives, where all these standard libraries live, and things like that. But you can also, you can also host it through any website, really, as long as it follows that convention. And so I've defined here, and I can reference something else by defining a repository in my pom.xml. So this repository gives a URL. I'll just copy that, and we'll just open it up here in the web browser. And here it is. I'm looking at stuff that's here hosted on my website, and here I've got edu pdx cs410j and examples. So it's got the same stuff. It's got some other stuff too because it's been using it for a while. But here's the same jar. So this is a remote repository. Okay, so repository manager. So these are just files served up over HTTP, right? Apache is just sitting there, oh, I request this URL, it returns this content. No big deal there. However, there are pieces of software, and you mentioned a couple of them, like Nexus and Artifactory, that are management systems on top of a Maven repository. So I'm familiar with Artifactory. We use it at work, and what it does. Oops, I forgot to set the timer. Otherwise, I will blather on forever. Let's do 30 minutes. What Artifactory does is it provides a decent user interface for browsing through the repositories, for finding artifacts, for you can deploy artifacts, you can control credentials around who can and can see various artifacts, things like that. You can also, I believe, both Nexus and Artifactory allow you to mirror other repositories. And so this comes in handy. I mean, so for instance, this is code that you are including in your application. So you can imagine that Tripwire, especially as a security company, making sure that our code is secure is very important to us. So we don't trust just any old artifact we might get off of the internet. And so what we do is our build system does not go out to the web, then the internet, to download artifacts. It only downloads it from our Artifactory instance, from our managed instance. Of course, we want to use artifacts like JUnit and Hamcrest that are out there, but what we do is we have basically a proxy to that, and there's a workflow by which a new artifact is brought in from Maven Central to our Artifactory. We make sure that it's good. We verify the checksums. We go look in databases to see if there are any vulnerabilities in that software, and then finally we include it. And so the reason that there are these artifact managers, the repository managers, is to provide that kind of functionality. Does that make sense? Is that all interesting? You're all checking your Facebook. Okay, cool. Okay, good deal. Good questions. Anything else? Okay. How many have you guys had a chance to watch either of the screencasts that I posted in the last couple of days? The ones about the file I/O and the libraries, the library APIs. Okay. I think I want to quick hit a couple of highlights from that because I didn't have much of a chance. Here again, I just rushed that stuff out over the last couple of days. So there are a bunch of standard libraries in Java and packages like Java-Lang and Java I/O. Let me do this. We talked about this a little bit already. There is a class called Java-Lang Object. It's the root class of everything else, and it gives you some methods. Things like we've encountered already, like toString, but then also methods like equals and hash code that are used by the collections classes, which will be in the ends of these slides. Sort of things for next week to talk about. But it means that every object can compare itself to another object, and every object has a hash code. String, I think we've seen. Strings are immutable, but string builders can be changed. And so this is where you can build up a string out of other pieces, parts, like you can append strings to numbers, to objects, all sorts of stuff like that. Wrapper classes, the whole idea here is that for every primitive type, like int or long or short, there is a corresponding object type, corresponding class, and this allows you to use primitive values in APIs that only require objects. And here again, when we learn about these collection classes next week, we'll see that you end up using these wrapper classes, or there's something magical called autoboxing, which will automatically convert something like a number literal 4, an integer int literal 4, to a Java-Lang integer object. Exceptions. Well, all exceptions descend from a base class called throwable, and this is where you have things like get message and print stack trace that you can get more information about the exception. And there are a whole bunch of different kinds of exceptions. I think the most interesting thing is that there are runtime checked and unchecked exceptions. Did you guys talk about this distinction when you learned about Java before?
Checked and unchecked?
Yeah, checked and unchecked.
We talked about last time.
Okay, so the whole idea is that checked exceptions have to either be explicitly caught, or you have to declare that your method throws them. And these are exceptions that are not terribly surprising. Things like file not found exception. There are also things that you can recover from fairly easily. Unchecked exceptions are things that could occur, well, in many places in your program. Things like a null pointer exception or an array index out of bounds exception. And they don't have to be caught, right? If you had to catch every null pointer exception, you have to wrap every object reference with a try catch block. That would make your code unreadable. So they make this distinction between checked exceptions and unchecked exceptions. and the checked exceptions are what I want you guys to experience in this class, because you probably have, well, obviously, you just said you haven't worked with them before. Because because it's part of your API, part of your interface. So you think about a method declaration, public int read port takes a file name and might throw a file not found exception. Think about what all that's telling you. Okay, public, anyone can use this method. Int, here's what it's going to return, here's its name, here's what input it takes, those are the parameters, and if something goes wrong, here's what happens. In many respects, that throws clause is part of the documentation of your method. And so, so checked exceptions can help raise visibility of what can go wrong with your program. That being said, checked exceptions can also make your code kind of hard to read, and is an exception. It's what happens when something goes wrong, and how likely is it that something goes wrong. And so checked exceptions have kind of fallen out of favor in the Java community. People prefer to use runtime exceptions or unchecked exceptions because, well, they don't have to be caught. And if you document it in your API with like an @throws in your Java doc, then hey, anybody who wants to catch it is free to, but they don't have to catch it. So there's an important distinction there. One of my okay, so I'm a big fan of checking your assumptions when you're writing code, and I think a really good way of doing this is using the assert keyword. Does anybody use asserts in C, or do they talk about asserts? No. Okay, you're familiar with the concept then. So the whole idea is that as you're writing your code, you're probably making certain assumptions about things that have gone on. So for instance, you're dealing with some number and you're assuming that it's greater than 0. And maybe you've checked this, or maybe it's because of the math you're doing or whatever. Damn it, this number better be 0. And if it's not 0, then my assumption was wrong. The logic that I had in my head when I was writing my code was wrong. You can validate those assumptions by coding them up in your code and asserting them with an assert statement. So the whole idea is that you can say, hey, I'm in this at this line. I'm going to assert that my value n is greater than 0. And if it's not, the catastrophic error, an assertion error occurs. It's a bad thing, and your program blows up. I recommend that you use assertions in your programs. I'm not going to talk about cloning. I'm not going to talk about covariant returns. Okay, so anyway, there's a set of slides in a screencast that sort of goes into detail about some of these APIs, some of these classes that are fundamental to the Java programming language. The other set of slides, and I'll go through this a little bit more slowly, I think, is about the classes in the Java I/O package. I'll skip through file, but the other stuff is probably more interesting. So you guys have done I/O, right? Written the files and C and stuff like that, and used the left shift operator, all sorts of good stuff like that in C++. Java takes a different approach, and a pretty different approach. If you learn C++ the way I learned C++, I didn't even realize there were objects involved. I just thought it was magic, and then after I learned Java and then went back and learned a little bit more C++, I saw that, oh, okay, it's not really magic, but they don't seem to teach it. They seem to teach it as magic. Anyway, there's a class called file that represents a file, and it gives you all sorts of information about the file, like its name, whether it's a directory, and et cetera, et cetera. So this file object, I'll skip through this stuff you can watch in the screencast. And so you've got a file that represents a file, and then when you want to do stuff with files, or if you really want to do any sort of I/O, there are two ways of doing it. The first one, which was there originally in Java, is something called input streams and output streams. So the whole idea is that you've got this class hierarchy of, getting stuff out of the VM, and then the whole stuff for getting stuff into the VM. We're actually doing I/O between, let's say, a source and a destination. It could be within the VM. So at the root of the hierarchy is something called output stream, which basically has a method, I think it's overloaded to take various arguments, called write, that writes bytes to some place. This is abstract, right? It doesn't know where to write them, it just writes them someplace. And the contract it provides has only a couple of methods. It's like write some bytes someplace, close the stream, and flush any pending output out to the stream. And so that's the abstract class. Everybody's got that. And then there are a whole bunch of subclasses of output streams that do various things, that write to various destinations, like a byte array, or to another thread, or whatever. There's also a file output stream, which writes to a file. And so it's like you create your file object, and you wrap a file output stream around it, and now you can write bytes to a file. Now, maybe writing bytes to a file is what you want to do. Hey, you just generated an image, write bytes to a file. But if you want to write other stuff to a file, you've got to convert them to bytes first, and then write them out to the file. And so there are a bunch of other types of output streams that called filter output streams that take one kind of data, turn it into bytes, and then write it out to another kind of output stream. So, for instance, there is a data output stream class, which is for writing Java's primitive types, your ints, your shorts, your longs, strings, stuff like that. It's out to someplace else. So all a data output stream knows how to do is take an int, for instance, break that int down into its constituent bytes, and then write it off to someplace else. So here's an example of how to write some doubles to a file. So what this program does is it's got a couple of command line arguments. The first one is the name of the file to write to, and then the rest of the command line arguments are coming as strings. We parse them as doubles, and we write those doubles out to the file. So the first thing that we do is we create a file output stream around for the file whose name is an arg0. So now we've got a file output stream that allows us to write bytes to a file. Well, we don't want to write just bytes to a file. We want to write doubles to a file. So then what we do is we create a data output stream around that. Now the data output stream knows how to write doubles, right? Data output stream is the thing that has the write double method. Then we go over the rest of our command line arguments. We use double.parseDouble to turn them into doubles, and we write them out to the data output stream. That operation, so the data output stream, what does it do? It turns that double into bytes, and then sends those bytes to somebody else. It sends it to the file output stream. That's sort of that's next in line, and then the file output stream knows how to write bytes to a file. The important lesson in this, besides this is how you write stuff to files, is that we've created what I like to call the object onion. We have all of these classes, all these objects that have very specific purposes, right? So the data output stream, all it knows how to do is take things like a double, turn it into bytes, and then let someone else take care of it. Similarly, the file output stream, all it knows how to do is take bytes and write it out someplace. Because we have limited the scope of these objects, because they only have a single responsibility, they're much more flexible, right? And so basically what this design pattern is that you have a bunch of different objects that all have a little bit of functionality. And you've sort of got a toolbox where you can take things, or Legos, right? You can take this thing and that thing and sort of plug them all together. And because there are these well-defined interfaces between them, they all work together very nicely. And this is a really important principle in object-oriented programming, having this single responsibility, having very limited scope, right? You could imagine that, gee whiz, I could have a file output stream that knows how to write doubles, knows how to write strings, knows how to write all sorts of other things, but that's too much responsibility for one object. Because think about it this way: if you had that same contract, so you had to write to a file, you could write bytes and doubles and longs and everything like that. If you wanted to write someplace else, like a socket, right over the network or to a database, do you really want to have all that logic for converting doubles into bytes duplicated for each one of those guys? You don't, right? You want to keep that logic in one place. Another thing about single responsibility is that you're sort of good at one thing. So the data output stream can be an expert in converting doubles to bytes. And it also knows how to convert strings into bytes. And things like that. But it doesn't know how to write to a socket. It doesn't know how to write to a file. That's someone else's responsibility. But because you have, because you have good contracts between the two, because you have a good interface between the two, you can combine them all. Anyway, have I driven this home? If I haven't driven this point home enough, go and watch it on YouTube. I guess that's it. Any questions? No? No? Okay. Anyway, this is the kind of stuff that you're going to need to know to do your homework. So that's for getting stuff out as streams, as bytes. On the other side of the mirror, there's the input stream hierarchy, which is all about reading from various sources as bytes. And it basically works in reverse, where you've got a read method on this abstract input stream class, which is then implemented by various things such as file input stream, which is for reading bytes from a file. Here is the example of reading that same file with these doubles in it back. And so I'll create a file input stream which lets me read bytes. I don't want to read bytes, I want to read doubles. So I create a new data input stream around that, and I will read it until, I'll read a double from it, I'll print it out until I get an end of file exception, and then I'll move on. And here again, when you're working with these input streams and output streams, if something goes wrong, you'll get an I/O exception. What are some things that could go wrong in this program? Files empty, right, or malformed. So maybe so doubles. Each double is 8 bytes, 64 bits. If your data gets truncated or is corrupt or whatever, it's going to try to read all 64 bits, all 8 bytes of that. If it only reads if it only reads 7 bytes, it's not going to know what to do. It throws an exception. Good. So yes, if the file is empty or corrupt. Anything else?
Or it doesn't exist.
File doesn't exist. Good. Hard disk crashes. Probably got other problems. But anyway, yes. So these are the kinds of exceptional conditions. These are the kinds of things that can go wrong when dealing with this simple program. This is where the exception will get thrown. Okay. So streams, the input stream and output stream, awesome for bytes. Character data, though, text data, was more complicated because you've got to text data can there are all sorts of different encodings, and you've got Unicode to deal with, and the streams didn't handle all that stuff. So in the next release of Java, they added this reader-writer hierarchy, which is similar in concept in that you've got this abstract writer thing, and they've got all these implementations of it that write to various destinations. You can write characters, etc., etc. So you've got like a file writer that writes to a file. And here I have an example. I go into detail, up on the screencast about how you can do things like wrap a print writer around something like system.err. And now you have that writer interface where you can write a string and have everything encoded correctly, but it goes to standard error. Okay. Similarly, you've got readers, and you can read characters as, actually, is it character array or is it strings? I'm pretty sure it's character arrays. And then you can turn that character array into a string if you really want. This example is interesting. Probably one of the first things that you learned in CS 101 is how to read from standard input. Right? Because of course it's 1970 all over again. We're reading from the terminal. If you wondered how to do that in Java, it's maybe not so surprising that it's not easy to do this in Java because no one does this anymore. So why make it easy, right? Or rather, why optimize your language and your libraries to make that easy? In order to read from standard input, first of all, you need standard input, which is system.in. So there is a class called system, which has all sorts of things sort of related to, system is sort of like the operating system, or like the OS that you're dealing with. Things like, hey, what the current time is in milliseconds, and system.exit, for instance. So sort of like the VM environment. And you can get a reference to standard in. Actually, it is an input stream. So standard in, you can read binary from it, right? Because you can pipe, binary into standard in. You can read bytes from it. I don't want to read bytes, though. I want to read text. So I need something that takes an input stream and lets me read text from it. Well, there's a class called input stream reader, which here again, you wrap this input stream reader around system.in. Input stream reader reads from an input stream. Okay, now I can read text from standard in. But I don't want to read just text. I want to read a line of text at a time. And so I wrap a buffered reader around that, because buffered reader is the thing that has read line. And so what buffered reader does is it will read characters from a reader, any old reader. It could be an input stream reader, it could be a file reader, whatever. It'll read characters until it gets that new line, poof, here's your line, and returns it. Again, it's this whole single responsibility. So input stream reader knows how to do, what it knows how to do is read characters from some input stream. And what buffered reader knows how to do is read enough characters until it hit into the line and then return that line. Anyway, and so then what you do is you loop until you hit the value, until you've read -1 on the line, read each line, and then we're going to buffer it up in a string writer, which is just something that implements the writer interface and writes not to a file, not to a socket, but to a string in memory. And finally, you print out the value of that string that was built up in memory by saying system.out.println. Is any of this stuff familiar to you? Did you guys do anything with I/O in like 202 or RC Java 4? Okay, good. So not terribly unfamiliar. Although I would encourage everybody to go and spend some time with the screencast to get all of the gory details, because this is the kind of stuff that you'll be doing in your assignments. Okay, cool. So that in whatever it was, 10 minutes is a condensed version of the things that we see in the screencast. Yeah.
What's the NIO?
Okay, NI. So there's something called, there's Java I/O, and there's Java or Java X NIO. NIO is new I/O. So the I/O stuff that you can do with Java I/O, ultimately pretty simple and straightforward. It's just basic file manipulation. Java.NET has basic sockets. There's a whole bunch of sort of buffering stuff in memory. Really, they have these nice abstractions. But they aren't necessarily terribly performant. And more and more operating systems are exposing like the raw file system files, and there's all of this fancy memory buffering that you can do. What new I/O does is it provides a Java abstraction over those kinds of things. So if you need super performant I/O, whether it's networking I/O or whatever, with all of the buffering and the raw file access and stuff like that, that's where you use NIO, the new I/O. And also, so there was the original NIO, which was probably a long time ago, probably 10 years ago. And in Java 7, I think it made it Java 7. They have new I/O, for lack of a better name, which not only provides, here again, sort of neat buffering performant I/O, it also provides abstractions over the file system and more stuff from the file system. So, for instance, now things like file permissions and echoes on Windows and stuff like that, they have Java APIs for getting those, and it's consistent across operating system. So now you've got abstractions over things like file permissions and information about the file system and stuff like that. So because it's so recent, there's actually a lot of good videos out there to watch and lots of good resources. So yeah, new I/O.
Is that going to deprecate the other libraries eventually?
Not really, because not every application needs a sort of like complex scaling, memories of shared memory and all that. Right, there is a whole suite of, I'd say the vast majority of I/O is just plain old file stuff, right? You're reading and writing files. You don't need big memory buffers and taking advantage of graphics acceleration or whatever they're doing. So no, I don't think, it's not really meant to supersede the I/O that's there. It's really advanced I/O for Java applications that need it, and a lot too, and some classes of Java apps need that.
Nice.
Good question. Okay, how are we doing on time here? Okay, another 5 minutes. Okay. Well, you know what? I don't want to forget about the assignment, so let's just do the assignment now, or talk about the assignment now, rather.
You can do it for us if you want.
No, you don't. You don't want me doing your assignments, trust me. I probably grade myself pretty low. Oh, look at that. Okay. Oops. Okay, so in project 1, we started an appointment book application. Pretty straightforward, right? And if anyone started on the assignment, it's just like, wow, read the command line, create a couple objects, and you're done. And that's on purpose. Project 2 builds on that, and the functionality that you're adding will store the contents of an appointment book to a text file. So what I want you to do for Project 2 is to write classes that, well, read and write an appointment book, and its appointments, to a text file. And the format of the text file is whatever you like. I guess the only thing that I ask is that it is text. Don't write it as binary, because one of the things I'm going to grade you on, I'm going to look at the file and see that as text, and when I add something, I want to see that something that looks reasonably like that was added, or at least the file got bigger or something. So the goal here is that I want you to experiment and start to use some of those I/O facilities that I talked briefly about and more in the screencast. And then also throw exceptions, because as you can imagine, now you're reading stuff not just from the command line, but from the file, and bad things might happen. So there are a couple more classes that I want you to add in your package. I want you to create a class called TextDumper that implements an interface that I wrote called Appointment Book Dumper. And what TextDumper does is it takes the contents of an appointment book, including its appointments, and writes it out to a text file. Here again, the format you're choosing. Text Parser does the opposite. It implements this appointment book parser interface, and what it does is it reads the contents of that text file. Again, it's only got to read your text file format. There's no way that we could have a shared one in the class. So whatever your TextDumper writes out, your text parser needs to read in, and from it, it creates an appointment book with its associated appointments. This is all driven from a class called Project 2 that has the main method. And what does it do? Well, first of all, if there is a text file, if the -text file option is provided, it will read the contents of that text file. It'll create a new appointment based on the arguments on the command line. It'll add that appointment to the appointment book, and then write out, if that text file option is there, it'll write out the appointment book back to the text file. And so here's what you have on the command line. So you invoke it with Project 2 main. There are options and there are arguments. Arguments are required, and they appear in this order. There's the owner, there's a description, begin time, end time, just like in Project 1. There's a new option here called text file, and that's where you read or write the appointment book info. Text file is optional. So if you don't have text file, then basically you have Project 1, right? So it shouldn't fail if text file isn't there, and you shouldn't attempt to write out the appointment book if text file isn't there. Note that if your text file does not exist, then a program should create an empty appointment book. Otherwise, there's no way to bootstrap the text file, right? So it's not like I'm going to guess what your format is and try to type it in myself. If the first time that I run your program, I'm going to have it with -text file, it should not complain that the text file doesn't exist. Instead, it should just silently ignore that fact, create the new appointment book in memory, write the new appointment, add the new appointment to it, and then write it out to text file. Does that make sense to everybody? Every year, I was just someone saying, "But wait, how do you But the file didn't exist. Of course, I'm going to complain about it." It's like, no, how do you get it started? C++. Anyway. That's not true. I don't hit people. Should I show an error? Oh, and just to be clear, dates and times specified in the same format as last time, the 24-hour time. Any questions on the command line before I move on? No? Okay. I guess one more thing. You shouldn't have to modify your appointment and appointment book classes from Project 1. That being said, I still want you to submit them. So please, always submit all the code required for your project, even if you didn't change it from last time. It makes it easier for me because I don't need to go find your submission from last time. And B, in my experience, even if you don't think you modified it, you might have modified it. So just be safe and submit all your source code. Yeah?
Would we have to modify it to take the new command line off?
Yes, but the appointment and appointment book classes probably don't have to modify them. But you're right, it's a different, and also the main class is now called Project 2, not Project 1.
So are we actually changing that Project 1? Because I created a whole Project 2 file, like project2.java, and maybe I don't know what I'm doing, but how do I get it to run that, when I package it, how do I get it to run that Project 2 instead of the Project 1?
Well, first of all, they have different names. Right. There was a ding gong. You win a brand new car. No. You go as an excellent question. So the way you do it, and let me just bring up IntelliJ here. Do I still have my student from last time? Oops. Open project student. Not student. Appointment book. Open project appointment book. Open in a new window. Here we go. It's too big. The way you change it is that you go into your pom.xml and you go find the jar plugin and you change the main class to be project 2. So that way it's that way that's what is in the manifest that controls which main class is executed by the executable jar. Good question. Good question. So yes, you'll end up with two main classes, two classes with main methods in your project, project 1 and project 2, and you'll need to change the name of the main class in your POM. If you were using IntelliJ or probably other smart IDEs, and you simply renamed your project 1 to project 2. Refactor. Where are you, buddy? Here we go. Refactor. Rename. Shift F6 and change the project to project 2. It says yes. Okay. It asks you, hey, do you want to rename your tests? Sure. What the heck? And it wasn't smart enough. I was hoping that would also. Oh no, I think it did rename it for me. Let's try that again. Oh yes, I want to rename that. Oh yeah, it did. So I guess it didn't prompt me that I was going to do that, but it was smart enough to know that I referenced that project 1 class off in my POM and automatically renamed it. Hey, good old IntelliJ. Anyway, but yes. So and actually, I think we'll take a look at some of the IntelliJ's tools for refactoring tonight, and in the course of doing some live coding. But tools like so. I guess what I'm saying is that if you learn to use your IDE, you'll get nice benefits like this because it's very smart. Okay.
So is that a better idea just to rename project 1 instead of create a whole new project 2 file?
Probably because
Well,
I guess if
I'm
it.
reusing anyway. So.
Sorry, what?
Like a lot of it I am reusing anyway, so that's.
So yeah, either renaming it or if you want to refactor things into a common superclass or something. But I think in general, either copying it or renaming it will be the best option. Okay. So there was the timer. Let me stop the recording, and I'll start a new one.